Hi, welcome everyone. Welcome to the November Gen3 Community Forum. Um, Today we're going to talk about how you test code using the new Gen3 testing framework. I'm excited about this since the team's been working on it for a while and putting a lot of effort into it. But also it is going to make it is going to really help external or groups that are not external contributors, sorry, to Gen3, so they can make sure that their code changes that they're proposing work. So it'll I think be very interesting and helpful. So next slide, please. So this is the agenda. We're going to give you the background on how to contribute code to Gen3, some more background on integration testing, how do you use the new framework, a couple demos, and then how to write your own tests. Next slide. So just before we get started, I wanted to do a couple quick announcements. Um, so the next Gen3 Community Forum is going to be in January, January 22nd, 23rd, depending on where you are. And that meeting is going to focus on the Gen3 product roadmap for 2025. So last year we did one of these, and we're going to do that. It's an annual event releasing a roadmap. So we'll tell you what's in the queue, both from CTDS, but also as we know, as we learn about it from community members. So we're looking forward to that. And then the other thing I wanted to highlight for everyone here is that we are kicking off a working group focused on common security operations centers. So these are organizations that host or manage multiple Gen3 systems. And so we're establishing this working group to to better coordinate with those centers and support them. Specifically, we're looking into setting up dashboards that make it easy to maintain and operate Gen3 systems, but it's a little bit broader than that to coordinate and find other ways to make it easier for organizations that manage multiple Gen3 systems.
And
So,
and for organizations that do so to contribute their code to a common code base.
exactly. So we have a kickoff scheduled in December. It's open to anyone. Um, there's some links here. When I share the slides, it'll be easier for you to access. But feel free to join, and we're looking forward to kicking that off. Okay, so next slide. Actually, Peter, did you want me to do the slide? Sorry, I should have coordinated that ahead of
Oh,
time.
uh,
Can I, before we start, can I just do a general introduction?
Oh, please, Bob, go ahead.
Yeah, I just want to back up and remind people how we got to this community forum event. Um, we are the group at the University of Chicago has done a number of things to make it easier for the community to contribute to the open source code base. They've changed the process for reviews, et cetera. But one of the things that was hard for external contributors when making pull requests was to adequately test their code with all the tests that are currently run so that pull requests don't break any of the existing Gen3 commons. And so there's been an effort that took quite a lot of work over the past year to create a testing framework that could be used by anyone, anywhere, in any organization, so that when you have a pull request, and when you have a code contribution, you can test your code with this testing framework. And so this is, you'll see some of the people contributed, but this was a lot of work. But I think it's very important in terms of opening up the code base so it's much easier for contributors anywhere to contribute code. So back to you, Michael, and to Peter to talk about some of the specific, to dive down into more detail.
Thanks, Bob. That was a really good overview. Um, yeah, so Peter, I'm sorry. Do you want me to start here,
yeah,
or do you want to?
sure. Why don't you give an introduction to this, and I may add some color commentary if
Okay,
as I
sounds
move
good.
into my part.
So I just wanted to set the stage again for where these integration tests come into the workflow. As Bob mentioned, we have made some progress, some considerable progress over the last year in our ability to accept external code. And so there are contributor guidelines already available for the community, which we encourage you to review prior to submitting pull requests. And I just wanted to give you the highlights there to show you where this kind of fits into that workflow. So if you have an idea, reach out, ask questions. It's better to ask questions first than to spend a lot of time on some code change that for whatever reason we might ask you to modify based on security concerns or support concerns, a handful of other reasons. So yeah, please reach out. Uh, you can also post feature requests or issues in GitHub. So that's another way to give kind of feedback to the team that is not a pull request exactly. So please feel free to utilize that way of interacting with the Gen3 code. So once a PR is posted, we will review and then may ask questions or request edits. We will try to merge quickly, um, although we may request minor or significant changes. Um, as I was mentioning, there may be situations that we cannot accept certain features due to security, maintenance costs, or lack of alignment with the Gen 3 roadmap or vision. And the other thing that we have been requesting is to run existing Gen 3 integration tests and provide any new tests needed for your code change. But we hadn't really given you a good way of doing this. So this is what we are now going to demonstrate today. So Peter, over to you.
Sure. Thanks, Michael. You can go ahead and move to the next slide. Yeah, thanks. All right, so I am really pleased to be able to share with you all this update on the status of the Gen3 integration testing framework. As both Bob and Michael mentioned, it's been a little bit of a journey to get to this point. We've invested a good number of months in thoroughly modernizing the framework, rewriting and expanding the tests, preparing some documentation to make it more accessible and easily used, and exercising the tests many times to make sure that they're robust. The primary credit for this really belongs to our SDET team. So our principal engineer and test, Hara Juvvala, and our excellent SDET, Krishna Agarwal. And you'll be hearing from both of them as we go forward through this, through the technical description, the demo. There's also a lot of help has come from the platform engineering team. And so I want to call out to them also, because one of the motivators for this, one of the confluences that made this possible was the release of the Helm charts for using Gen 3 with Helm. And this allowed us to start creating more standardized and easily accessible ways of deploying Gen 3, which meant we could standardize the tests against that instead of against our internal environments. And I'll cover that briefly, but then I'll let us, get to the meat of the technology and the demo. For a project like Gen 3, integration tests are essential. Even internally, as we change the front end and the front end exercises various services, we need to be able to validate that that end-to-end flow is correct. But given the number of services and the complexity of the various interactions, it's important that we also be able to test for regressions whenever changes are made. And this has long been a complicating factor for accepting external code, because Gen 3 is so configurable and there's so many options that running robust integration tests has been a challenge. We've run them internally since long before I got here. And it was, for efficiency, we had a number of environments that existed. We would run the tests in the next available environment. At one point, we were standing up like one of any of several configurations of Gen 3 just to test the generality of things, because there's always a specific configuration of Gen 3 that we're running in, but the code needs to run in all of them. And all of this introduced complexity, but it also meant that it was specific to CTDS. It was specific to our internal environments, and our integration tests reflected that. And so the big effort here at an abstract level was to remove all of the direct infrastructure references from the entire test framework and make sure that it could be run generically on your infrastructure. The introduction of Helm made that a little bit easier, so we were able to align with that. And there were some other challenges along the way. We needed to make sure that we could run scripts from outside and invoke them, during the test flow. We had built, like any complex system over time, there had been some accretion of unfortunate dependencies that we've removed for this. So now it's possible to run tests fully in parallel. The tests are idempotent. We have, spent a lot of time cleaning that up. Some of the key changes, and I'm not sure if this will explicitly get called out later, so it's not on the slide, but one of the primary motivations that we had, in addition to making this available for the community, and making it available in a way so that you could run the integration tests and we could run the exact same integration tests. So we could see what you were contributing to the code. You could know in advance whether or not it was passing the test suite that we provided. You could update those tests so that we could run the updated tests for your contributions, and we would all be on the same page. In the past, if external parties had their own integration tests, they were also specific to their environment. And so there wasn't this easy exchange. The community couldn't benefit from collaboratively developed tests or increasing the test portfolio. And it made the handoff for testing things really rather difficult on both sides. And so one of the changes to facilitate that, we rewrote all of the tests in Python. Previously, they had been written in JavaScript. But most contributors to Gen3 are working in Python, and it seemed to make more sense to get the language as close to the language of the code as possible. So yeah, so we've, I think I'm just going to hand off to Hara and let us get directly into the technology description of what it is that's been done. And then maybe at the end, I'll come back with a few more comments on how what you've seen aligns with our objectives. So take it away, Hara.
Thank you, Peter. And yeah, so can I share my screen for this part so that I can switch between code and the presentation? All right, so yeah, as Peter explained, already described, we try to use widely used technologies and tools for this framework so that it's easier to learn and adopt the integration tests. So I'll talk about the technical implementation details of it here. So the first of the libraries that we picked for these are listed here. So PyTest is a widely used Python testing framework, and it forms the core of our integration tests. We use Playwright for browser automation. It's a web automation tool. Yeah. For handling Gen3 tasks, so Gen3 SDK is an SDK built by us in Python, and it contains it has code to handle many Gen3 common tasks, particularly wherever we are interacting with the Gen3 APIs. So if you have some operations where you're interacting with fence API, indexd, or sheepdog, we have all the general common functions available in this SDK. And we are trying to use the Gen3 SDK as much as possible wherever the methods are available. However, some of the functionality is not general enough or generic enough to be a candidate for Gen3 SDK, where we, for example, when we do negative testing, so we want to hit an API and want the interaction to fail. So in such scenarios, we use requests to directly interact with the APIs. So requests also is very popular HTTP request tool. Allure is a reporting tool, and we use the Python port of Allure for reviewing and analyzing the test results. And finally, another major component is Xdist. It is a PyTest plugin which allows for parallel execution of tests. It depends on the multiprocessing library of Python. So it basically is distributing tests across workers and running on different CPUs in the machine. So I also want to highlight that this integration with Gen3 SDK was not possible in our previous integration test framework because that was a JavaScript based one. So that's about the primary libraries that we use. And coming to the way code is structured, the code is organized as test suites. Each test suite is a test class. And so PyTest allows us to write tests in different ways. We could have one module containing all the tests. We could break it up into multiple modules, or we could also break it up into different classes. So we chose that option. And each test suite has multiple test cases. And the parallelization that we have is at a test suite level and not at a test case level. The reason is that setting up the application state and test data, it takes time and resources. So doing that for every test did not seem optimal. So instead, we just do it as a test suite, at a test suite level. And so these are, I'll also talk about a little bit about the directory structure for anybody wanting to develop new tests. So we have primarily, these are the primary directories. So we have tests, as the name suggests, it has a test. Test data has the test data. For browser automation, we follow the page object model, which is a very common design pattern. And all the page definitions are in the pages directory. Even for API interactions where we are hitting different microservices of Gen3, we have organized it in a similar fashion in the services directory. So we'll have one module for each service or functionality. So in some places, we also grouped it by functionality. Utils contains all the common helper functions, which are used across the tests. We also have some scripts which are basically to help us. They are not part of the test used as during test execution, but they help us set up the environment and things like that. All such things we keep it in scripts. I will also open up and show once that is done. In PyTest, we can have multiple conf test files for those who are familiar with PyTest. Basically, conftest.py is a configuration for the PyTest. So we use a single conf test for configuring the test flow. And finally, this is an important piece. The test, as part of test flow, we also perform Gen3 operations and administration tasks. For example, creating a fence client or running ETL job or running aggregate metadata sync job. So these are not really done by APIs or from the Gen3 UI. So we need to, and the other challenge is the way we do these operations depends on how Gen3 is deployed. So for those of you familiar with cloud automation, so we can stand up Gen3 using cloud automation on an admin VM. And the way we run these operations is by using the Gen3 CLI. Coming to a Helm deployment, we have to just use Kubernetes commands. So for now, we just support a couple of models here, and it's all centralized to one module so that if somebody is doing a different way of performing these operations, they can just override one library. So I'll just quickly walk you through the code too. So like I said, we have the structure. So we have tests, test data, pages, services, utils, and scripts. And the tests look like this. So we have one module for each of them. Technically, we could have one module having multiple test classes, but we just separated them out. So the way our code is, there is one module, one class, and test cases for that particular test suite. So this is aggregate MDS. So this is the test class. And under that, yeah, there is a test case under that. And we have the scenario description and then the code. And so this is the test data also is organized in this. So I will talk about how to use the directory. So later when we talk about how to write the test. So there's pages for each of the pages that we have. So discovery page, exploration page, etc. And then similarly, we have services. So for some, it is just the microservice, like audit service. All the code related to that is to interact with audit service is here. We also grouped some things a little differently, like for example, graph py. This has all the methods required for creating and interacting with graph data. And that's that. I will quickly show you the conf test too. So this is the conf test which configures. The test, basically the test flow is defined here. We configure the tests and then we run that. There are a few like gotchas here that I will talk about in the further down the presentation. And yeah, so this is the admin tasks that I was talking about. So we have a module called Gen3 admin tasks, where we have all the things that we do on the admin VM or on the machine for managing the Gen3 instance. So for example, like running a Gen3 command or a job, for example, metadata aggregate sync. So as you can see, there are two models that are supported right now. So we could run these tests against a Helm deployment, or we could run these tests against an admin VM deployment that uses cloud automation too. And yeah. So coming to how to use the test framework. So before we get into how to run the tests, when we talk about how to use, we can also, I also want to describe the complete workflow. So for example, you have a new feature on fence. So you develop a new feature. So with the Helm, Gen3 Helm charts that are available now, it's possible to stand up the instance right in my laptop. So this gives us the flexibility of running tests with my changes directly in my laptop. So that was one of the motivators for this approach. So you can basically create an image of from your branch, change the image version on your Helm deployment, and run the tests. So there is a complete, there's a full-fledged document here. I will not go into this now, but these are the broad steps that we need to follow. So like I said, sorry. So we need to start up a Gen3 instance. I am talking about Helm more here because that's the way for a developer to easily test and develop software now. So these are the prerequisites that we need. We store all the test artifacts which are dynamically created by the test in a directory called .gen3 and in the home directory. So we need to create that. And also, this is technically not required. We could pass the environment variables as part of the command itself, but we're just standardizing how we do things. So create a .env file in your integration tests and store your environment variables there, which are needed to pass to the test. So the point to highlight is all our code is designed to pick up the environment variables from there. Then we need to set up the test users and user permissions. So let me quickly open up this and then I'll come back. So all the user related, so we have a directory called test setup in test data, which contains all the information for setting up your test environment. So the tests use these particular users. So these are not real email IDs, they're just dummy email IDs. And these are the accounts that are used for testing. So the tests are designed to test from multiple perspectives, like multiple personas, and with different permissions. So for example, indexing account has full permissions to interact with IndexD. It's an IndexD admin, whereas main account is not. So main account is used for all the general test flow. So, and each of these accounts has some specific purpose. And all these permissions are also available to you as a user YAML here. This is the standard way of managing permissions in Gen3. And you can set your environment up using this. And yeah, and these are the clients that we use for tests. So we do not need to manually do anything for this. The tests or take care of creation of these clients whenever they're required. That's that. Yeah. So once you set up your test users and permissions, part of that is also generating API keys for the users and store them in .gen3. And once you have this, you can also set up test data. So for most of the tests, the test data is also generated as part of the test itself, based on the some of the files that we stored in test data directory. But there are a few exceptions. So for example, Guppy, for testing Guppy APIs, we could also do an end-to-end test flow, but just to test Guppy, we do not need to create data in sheepdog, run the ETL and everything. We have files here that allow you to set up the indices as required for the Guppy test. So for the Guppy test, because we want to do test data validation, we want specific data to make sure that the API is not broken. And we have all the data here too for that. So, and also scripts to set up this data in your environment, depending on how it is. You will see a lot of references to Jenkins because Jenkins is how we manage running our CI and also running tests. When for instances that are running on an admin VM using cloud automation. And then we run the test. It's just using a pytest doc command. And then we can review the results using the ALU report that is generated from the test run. With that background, I will hand it over to Krishna for doing a quick demo. He will show you a test case and then also demo execution of tests. I will stop sharing now. Over to you, Krishna.
Thanks, Hara. I'll showcase the steps and how to run the tests on the workspace. So this is the GitHub repository for the Gen3 code.
Krishna, sorry to interrupt. Could you zoom in a little bit?
Okay. Is this better?
A little bit further yet. Okay, I think that's good. Thank you.
Okay. So what we are going to do is we are going to clone the repository onto our workspace first. So next, we are going to go into the Gen3 code visual and then the Gen3 integration test. So this is where all the integration tests reside. So before we run the integration test, there are a couple of steps that we need to do as part of the setup. So first thing, we need to make sure that the Python 3.9 is installed. So let's make sure of that. Oh, sorry. Yeah, and next we are going to set up the environment variable. So that is the .env file. So the .env file consists of all the global variables that we need as part of setting or running the integration test. So as you can see, we have two environment variables here. One is the Gen3 instant type, which is set to Helm local. And the second one is the host name, which refers to the host name of the Gen3 Helm environment that is set up. Next, we are going to create a directory called output, followed by running the.
Oh, sorry to interrupt again. Is it possible to zoom in the terminal window too? I think it does. Oh, a little bit further. Yeah, that's pretty good. But okay.
So next, we're going to do poetry install. So this will install all the Python dependencies that are required for running the integration test. And lastly, we need to generate the API keys for all the users that are needed as part of running the integration test. So this is the command. And as you can see, we have a shell script over here, which accepts two arguments. So one is the users.csv that Hara already talked about. And the second one is going to be the host name, which in this case is hara.dev.planx.planet. So let's go ahead and create this. And also I can just walk through the users.csv one more time. So under Gen3 integration tests, we have the test data, and under test data, we have test setup, and this has the users.csv. So the user ID and email is what we require in the CSV file. As you can see, the API keys are getting generated for individual users, and they're getting stored in the user's home directory /gen3. followed by the hostname underscore the user ID, whatever is there in the user.csv, and then .json. Also, we can go through the test suites that I'm going to run as part of the demo. So I'm going to run 2 test suites. So first one is going to be the test homepage. As you can see, there is one test case over here. And in the docstring, we have defined the scenario and the steps that would be needed for executing the test. And the second test suite that I'm going to run is the pre-signed URL. So it contains a bunch of tests that are there. And for keeping the demo short, I will run only 2 tests from here. So let me go ahead and comment out the other tests. Also, for one of the test cases, let me go ahead and introduce a failure so that we'll simulate a failure while running the integration test and further see how we can generate the reports and use it for debugging purposes. So for one of the test cases where we have an expected status of 401, let me change it to 201, and this will simulate a failure. So going back to the terminal, now that we have set up our environment, let's go ahead and run the test cases. So as you can see, the command here is poetry run pytest. That is followed by --allure dir, followed by allure results. So allure results is the folder that's going to contain the test reports once the tests are executed, followed by -n2 and --this load scope. So these parameters are required by the pytest extest in order to run the test cases in parallel. The next parameter that we have is the -m. So -m stands for markers. Each test suite has a marker associated with it. So tomorrow, if you want to run a couple of test suites which have the same marker, you can use the marker itself to, run those couple of test suites that you want to run. One note over here is we have some tests which might be in development. So those tests would be marked with WIP, which stands for work in progress. So in order to exclude those test cases, we have mentioned the -m as not WIP. So all the test cases which are marked with WIP marker, those will be excluded as part of the test execution. And the last one is the -k. So this matches the substring in different test suites and gets only those particular test suites which we are specifying in the values. So for the demo purpose, since we are trying to run the test homepage and the test pre-signed URL, I have mentioned these 2 over here. So let me go ahead and run this. So it might take a little while before the actual test execution begins. So let me walk you through what actually is happening in the background. So pytest is collecting all the test items from the various test suites that we have. And depending on the -m and -k values that we have supplied, it's going to select those particular test cases or test suites. So in this case, it's going to select 3 items, one from the test homepage and 2 test cases from the test pre-signed URL. Also, we have the user sync, which is running. So that will help us set up all the permissions needed for the users to run the integration test. Also, one other thing I wanted to highlight was in the conf test, we have this block for performing additional setup. So although it's not applicable in this particular execution, there might be a test case. So let me take an example, maybe the test client credentials. So the test client credentials has a marker called requires fence client. So basically what it means is this particular test suite needs the fence clients to be set up as part of running the test cases. So if I go back to the conftest.py, in this block, you can see that there is a mark if block which says requires fence client. And whenever the PyTest collects the items for the test cases to be executed and it finds this particular marker, it's going to go ahead and run the setup fence test clients info function. So this will set up all the fence clients. So that might add a little bit of more wait time before the actual test executes. So in future, if there are multiple or new test suites being added and it requires particular setup that is specific to that particular test suite, this concept can be leveraged in order to expedite the flow of the PyTest if the test suite is not even being run at all. So that avoids doing this additional setup. So going back to the terminal, as I mentioned earlier, we have two workers that we are trying to run this test suites against. So there would be two workers assigned. So one is going to be GW0 and the other is GW1. So each worker is running one particular test suite, indicating that we are running all the tests in parallel. So the number can be customized by the user depending on whether they want to change it or leave it to 2 as well. So now we are expecting 2 test cases to pass and 1 to fail. So once that fails, we will generate the report and see how we can leverage the report in terms of debugging the test case. Probably a couple of more seconds and this should be done. Okay, yeah, that's the failure. And the last step that's happening in the background is in the conftest.py, we have a section called the PyTest unconfigure. So anything that we're trying to do as part of the code, as part of the cleanup, so that can be handled over here. As you can see, we are deleting a directory, or if the fence clients were actually set up, this PyTest unconfigure will go ahead and delete all the clients from the fence side as well. Okay, so now that we have one failed scenario, let's go ahead and generate the report, and we can then see how we can use the report to debug. So the command to generate the report is allure serve allure results. So this allure results is the folder that we supplied as part of the poetry run PyTest, and it's part of the allure dir. And as an optional parameter, you can provide host localhost. So this page is the main page, which gives the summary of the tests that are executed. So it gives you 3 test cases and it says 2 pass, 1 fail. So when we click here, this gives a more detailed information based on the test suite. So since we had a failure in test pre-signed URL, let's go ahead and check that out. So as you can see on the right side, there are 2 sections highlighted in red indicating what the error was. And in the middle section, we can use this to get additional information like description. So this is the doc string that we had as part of the test suite. So this gives the user to more information about what the scenario was, what we are expecting, and why the error might have occurred. And secondly, we have a std out, which gives, so any output that is coming as part of the test run, that gets captured over here. So that also helps in troubleshooting. Now, if we click on this particular error, it's going to give you the exact line code where it failed. And developers or testers can use this information to do further troubleshooting or debugging. Since we already know what the issue is, let me just go ahead and revert back the change, and then I can run it again to confirm that all the 3 tests are running properly. So we run the same test again, and This time, all the 3 tests should pass. So while we are waiting for the test execution to complete, I can open up the floor for any questions related to the demo.
Hi, this is the OHSU team, and great stuff. We're very excited to see. And anyway, it's we'd love to kind of get this integrated into our Gen 3 system, and eventually we'll start having our own GitHub actions for it. And for non-local Gen 3 instances, what path would you recommend for setting up this test integration?
Are you using cloud automation?
Oh, we are, yes.
Do you want to take that, Hara?
Yeah. So yeah, I was going to show it when we do go through the code again. But there is a directory that I did not talk about in Gen3 integration test called Gen3 CI. And that has all the code that we are using to set up our CI. So it has a bunch of Python scripts. And also, as I said earlier, we are using Jenkins to interact with the admin VM. This is mainly required for any of the operations we need to do on the admin VM. So we have all the Groovy scripts for the Jenkins also right there. So it may require a little bit of change, or if you are just using the Jenkins setup we have, you can directly use it out of the box.
Got you. Oh, that's exciting, and we'll explore. I don't think we've taken full advantage of that admin VM yet, so that sounds like a good first step for us. Thank you. This is exciting.
Thank you.
Yeah, thank you for that, for the question, and and for the comment on enthusiasm. We're very excited about it, actually, and especially the ability to hand off tests, right? So that as you run tests, develop code, we can pass the integration tests back and forth with the code, and everyone can be running the same tests regardless of what their environments are.
Okay, so all the tests have passed, and that concludes the demo. So I can popcorn it back to Hara.
Krishna, could you also show the homepage test report just to show how the screenshots are saved? So wherever we have tests for that involve browser automation, the screenshots are stored in the same test report. So just FYI. Thank you, Krishna.
Thank you.
All right, so let me share my screen again, and then. All right, so that was a demo. Yeah, so now we will talk about how to write our own tests. So it's not, we should have mentioned here, but basically few questions before even we get here is when do we need to write a test? So you have added functionality to Gen 3 that's currently not covered by our existing tests. That means we also have to add an integration test. Or if you're changing some of the functionality, the integration tests also need to be changed along with them. So that's when. Now, yeah. So before I talk about how exactly to write a test, I just want to also highlight some of the design principles that we set for this repo. So Peter already mentioned this. All the tests must be independent and idempotent. Independence is at a test suite level, not at a test case level. The second point seems very obvious, but we had to explicitly say it because of past experience. So the test should be able to run anywhere without changing the test code. Only changes that need to be done should be to the Gen3 admin tasks code or Gen3 CI code. The test itself should not really care about where the application is running or where the environment is set up. Then this is also fairly obvious, but test code is well documented. And test steps are documented as doc strings. So we have a specific format for the test steps. You would have already seen when Krishna showed it. We have a scenario, describes the scenario, and then we have the steps. It's a little bit of BDD style of writing, but that's just a doc strings. And that's kind of mandatory because we do not want to end up in a state where we want to understand what the test does by reading the entire code. Yeah. So we do not want to have hard weights in the test itself. They should wait for specific application state. And we should mark the test correctly, appropriately using markers. And the markers are all added to the pipe project, the poetry configuration. And this is very, very important since we are in the open source world. We are running the tests in GitHub Actions, and the GitHub Actions logs are open to the world. So because these are public repos. So we should ensure that privileged information is not logged by the tests. So having said that, okay. So we talked about when to add a test. So where should we add a test? So if there is related functionality already in a test suite, we should add it to the same test suite. Some of these are obvious statements. But just making it explicit. So to add in completely new test suite, we need to create a new module under this directory. So like I previously showed. So we have tests. And so we can add a new module here. And within the module, you add a new class, which is basically the test suite. And then you have the actual test. Yeah. So all the reusable code is in one of these two places, pages and services. I already quickly showed that, but we can go into more detail if there are questions. The helper code is all in utils, where the Gen3 admin tasks are. And the test data is stored in test data directory. So if you want to basically get a file from the test data directory, there is a variable that we provide. So in utils, there is test data path object, which basically, maybe I can just quickly show that. So this points to this current test data directory. So you can just reference that and get the actual files. So, and yeah, so there is another, so there is a possible scenario where you want to group tests that are not in the same test suite. So as we talked earlier, Xdist has a flag called load scope, and that what it groups does is it groups all the tests in a particular class or module, whatever lowest level it can find. So in our case, it groups them per test class, and all of those tests are sent to the same worker. But then you might have a scenario where you want to group tests that are across different test weights. So we also have a mechanism to do that. I'll show that and also tell you why we had to do that. All right, so in the conf test, we have some custom scheduling mechanism. Gen3 workspace, we can only launch one workspace at a time in the commons. So if two parallelly running tests are both trying to do something on a workspace, that would make either or both of the tests to fail. So we need to group all the tests that are launching a workspace together, irrespective of which test suite they belong to. So we have written some code to override the default behavior of Xdist. Basically, it pulls out all the tests that have a marker called workspace and creates a custom group called __ workspace, dunder workspace. And this forms, all these tests go into a different worker as a group. So if you have similar scenario in future, you can basically follow the same approach. And yeah, so one other scenario is Krishna already showed this, but basically we run the user sync after collecting all the tests. Now, when we say tests should be independent, that means we cannot run any code that changes the application state. And user sync is one such thing, which changes the permissions briefly while it is running. So we cannot run that as part of the test flow. So for that reason, we have basically made sure that none of the tests require a user sync. But tomorrow, if you have a test that requires this, without doing this, you cannot test something. So the mechanism would be just have them in a separate thread, right? Run all the tests in parallel that do not have user sync. So we could just set up a marker and run it. So we recently came across a scenario that might require it. So I thought I'll just share that as well. And yeah. All right, so I will just walk you through one or two tests to just give a feel of how they look like. This probably is a repetition, but yeah, so as we saw earlier, we have a test module and we basically make sure it is containing only one test suite. So in this case, we have a homepage test. And there is a test scenario where we are just testing the navigation. This is technically not an end-to-end or integration test, like complex test, but we keep it. So this is kind of an early indicator of an environment issue for us. If this test fails, we first go and debug the environment. So all it does is it basically goes to the homepage again. So it opens up, there is a page object defined for home. So it contains a class with all of our page objects will have a base URL. Since it's a home page, it's just the root URL. But if the page is something else, it's a workspace, then it would be this /workspace. So rest of the class understands where to start off from. And this is kind of also standard, go to the page. In some places, we do some additional validation in that. And in the actual test, we are just going to the page, performing login. So login page is another page object. And do some assertions. So we just use assert of Python and log out. So that's the anatomy of a test. Maybe I can quickly show you also an API-driven test that we covered earlier. So in the pre-signed URL, here we're basically importing these, which are our services. So I have Fence as a service with all its endpoints and all the common methods. And then we just use that in the test to do operations. So we are also making sure that we tear down. So there's a setup class and a tear down class. So to keep the test to idempotent, meaning you can rerun the test multiple times without causing unexpected failures. And that's all about how to write a test. The actual writing of a test is very simple in PyTest. So, all right. So with that, I will hand it over back to Peter. And if you have any questions up to this point, please feel free to ask now, or we could do it after the.
Yeah, let's just wait till Peter wraps up and then we can open it up, Hara, if that's all right.
Okay, thanks, Hara. So, can you put the slide back up? Great. So I've alluded to these and called some of them out directly, but I mean, you can see there's a significant amount of work that went into doing this, to converting these, to making them run independently, to make them run equivalently in different environments, etc. The leveraging of tools which Python developers should be familiar with, I think, should be an accelerator for anyone who wants to help write tests, improve tests, or anyone who's building Gen3 code and wants to develop tests and contribute them with their open source contributions. So that said, the open source contributions now, not only can they include integration tests, but really, if you look at the guidelines, they really should include the integration tests. It will dramatically accelerate our ability to review and go through a feedback cycle and accept any contributions from the community. And it'll keep everyone using Gen3 safer if we keep the test suite up to date. But it's, in addition to participating in Gen3 open source development, now that the suite is public and the tests are public and they're a shared asset for all of us to use, community members can also participate in the improvement of the suite itself and the existing tests. So it's not, if you're running the tests and you see potential improvements, that's another opportunity to contribute to Gen3 and benefit the entire community in addition to accelerating your own projects. Tests that are run by external parties should essentially be the same as tests that are run internally, and tests that are run in different environments should be equivalent. So this should aid with the consistency and the ease of development. And so we will, I think we'll reap the benefits of that going forward. I think this is an investment that I am very much expecting will pay off as we go forward. Now, I think what's been done by the SDET team here at CTDS is pretty impressive. I think I should probably mention there's a couple of limitations. The test suites are complete, so they will run pretty much anywhere. The marriage with Helm, there's still some. Well, okay, there's a couple of specialized tests that we have not converted. So we do have tests that test our DICOM viewer, which is available in the open source product. It's exposed in Midric, for example. Those we will convert those tests because they were not as widely used as the other services. We wanted to make sure that we got the framework out here and a fundamentally complete set of tests for everyone to start working with. So there's a couple of tests, the DICOM, and then something that we're using, what's called the Argo wrapper. Those tests are not fully converted yet. And some things that might work in there might be some challenges if you're standing up and tearing down your environments with Helm. And one good example of this is RAS. We have fairly robust RAS functionality, but RAS works only when you've registered a client. And with RAS, right? You can't sort of fake that out with us. So you need test credentials from RAS in order to make that work. An ephemeral environment, possibly with a changing name, is really probably not going to work in a context like that. And this is not a limitation of the tests or the test framework itself. It's simply some of the obligations, the technical requirements for working with those external parties. So there's a couple of instances like this. They're mostly edge cases like that. We will continue to try to find solutions for them. Some of them, like RAS, I imagine, finding a solution is not up to us, but so you may need to test those out in a different way. So there's still a little bit of work to be done. We want to continue to try to solve these edge case challenges, and we welcome any input that you have to offer if you encounter them, or you can share your approaches with us. That would be fantastic. A couple of things that we want to do on our list. Number one, this works for testing changes to services very well. If you're testing changes to environments and configuration, there isn't an automatic way yet to mutate the Helm environments to test that way. And so we'd like some code to do that. There's some testing of data where we would like it to maybe be more robust. We have some generic data. We can generate data for the tests. But if there's very data intensive testing, we'd like to enhance those capabilities. And then we want to continue working with the platform engineering team and refining the capabilities of Helm to make sure that, basically we get rid of some of those edge cases I was discussing. One thing, actually, all of this that you just saw was running in an EC2 instance. So it was local testing, but one thing that we've been working on, and you can see it's fairly complete. It's not 100% there. In addition to the local configuration, you can configure your local device to basically to forward ports to an EC2 instance if you don't have a laptop that has the processing power or the memory necessary to run Gen 3 and run the test framework at the same time. That shouldn't be a barrier. You should be able to, to run these essentially by taking advantage of something like an EC2 instance, which is sufficiently provisioned to allow you to do all of this. So it was a little bit of a high wire act. I want to give kudos to the team for being confident in the code that they've built and the work that the platform engineering team and the SDET team have done to make sure that even that part of it, which is not finalized, we were confident enough to show to you through the demo and through the running of the tests. And I think that's it. I want to thank you all for your interest in this and for all of the contributions which you will be making to the code and to the tests going forward. We look forward to your questions and to your contributions, and I'm going to throw it open for questions for about anything that we've discussed so far.
Hey, Peter and team, thank you. This is amazing. By the way, just wanted to say you guys have done a great job if we kind of providing that, ability to extend and accelerate the code dev model. So kudos to you guys. I'm just going to put my security hat for just a second. And I just have two general questions. One is related to script injection in the process, and if there has been some work on the security side. I'm sorry to be the bearer of bad news, just to see how to make sure that some of the stuff does not kind of flow into potential, malicious activities. And then the number two related to that is a pure security question, or I'll say it's related to like potentially detecting if somebody's doing some of these integrated testing to making sure that they don't have like static credentials in their environment. Perhaps that's more on the, the owner of the code versus the what you guys are doing. But I'm just literally just looking at this from a security perspective.
Do you want me to start, or do you want to start, Hara?
I mean, I can just go brief end. So, yeah. So we are using GitHub secrets for all the credentials that we have to use. The integration tests are running against, ephemeral environments right now, which periodically keep getting shut down. And also, the tests are running on a GitHub action runner, which is also ephemeral. The only concern that we could think of was logging stuff to GitHub actions logs. So we only, that's the one thing. And yeah, that's all I can think of, Peter. Like, I'll let you.
And the code is in, it's the repositories can be scanned the same way that anything else is. So I can't speak to what an individual developer does by modifying tests and running them locally, but code that is checked in to CTDS can be scanned by the same security tools, and we can check for presence of hard-coded credentials and things like that in GitHub.
We did the security review before making it public, so it went through the scans.
But it's kind of a big topic, Plum, I think it's a very important one. We did run this past our security team before making the code available, as Hara just said. We can, I don't know, maybe if you want, we can break out and talk about individual specific concerns that you have. I'm not sure
Yeah, right. I don't want to, Peter, thank you for this, and Hara, thank you. I don't want to take it onto that path because, like you said, Peter, this is a very specific topic. Generally, I'm not concerned, but these are certain things that just pop to mind. Certainly, we can have a further discussion on this. I just also wanted to allow other people to have the discussion about the great functionality that you guys have introduced. So I don't want to hog this and make this a security talk.
Thanks, Plum. Thanks for the feedback. Anyone else?
Hi there. Thank you for the talk. This was super helpful and very interesting. Wanted to ask a bit about the pages and the use of pages in the integration testing. How does that play with an existing front end, an existing front end that a user uses? Is it injecting that into is it being tested in conjunction with, or is it entirely separate from that? Are those pages used, independently from that, or is the front end framework also brought into the loop? Let me know if I can clarify that question.
Are you talking about the pages in the code that I showed, or?
Yeah.
Okay. So, yeah, I mean, they are just like models. They're basically classes which define what the page should contain. They do not have a one-to-one relation with the application or basically the pages on portal too. They don't have to. They're basically just a way for us to encapsulate all the related functionality into one place. That's all. So when I say login page, actually that's happening on the home page itself, but we treat it differently just for ease of coding. I'm not sure if that answers your question. Like, please clarify.
Yeah, that clarifies things. Thank you.
Also, the way Playwright works is it creates a virtual browser and does the operations in it and shuts it down at the end. So if your application is running on your browser, the automated test does not really touch that or interact with that.
Great, appreciate that. Thank you.
There's a question in the chat. Hara and Peter, if you can take a look.
So Hara ran through some high-level guidelines. There's a design philosophy which was presented in the slides. It's also should also be in the documentation. At a high level, there's a structure of the tests that you should follow and conform to the design philosophy, and the tests are fairly standard PyTest style. So if you're familiar with that might be enough. If we need to develop more description of that, I think we can. I'm gonna punt to Hara and see if he wants to add anything to that.
That's exactly what I was thinking. So we haven't formally written a document, step-by-step document on what to do, but yeah, the principles in general. So
there is a lot of guidance on writing. I mean, there's two pieces of complexity here, right? One is the using tests that work well in the test framework, and PyTest is very rich and widely known, but it's fairly easy to use the test framework, but it is very feature rich, but it's also extremely well documented. The other side is knowing what it is you're trying to exercise inside of Gen3. That's probably the harder challenge, to be invoking your tests that way. And yeah, maybe over time we can come up with additional documentation for that, but to some extent, it's going to overlap with documentation for using Gen3 itself. But a really good question, Irvi. We'll think. We'll try to see if we can come up with anything more to offer. Yeah.
Anything else in the community? Okay. Well, thanks, Hara, Krishna, and Peter. I know tons of work went into this, and it's looking really good. And I think, not to speak for you, but we're looking forward to hearing the community kick the tires and see how it goes. We'd love some feedback and can make any refinements that are needed. And just one other note, I'll be posting this video and slides in the next day or two. And so this will be, I think, a great resource for taking a look at the test framework. So please use it like that. All right. Bob, did you have any? Oh, I think maybe Bob had to drop. So does anybody else have any closing comments or questions? All right. Well, thanks again to the SDET team, and thanks to the community. Goodbye, everyone.
Thanks all.
Thanks, everybody.